Geometry, Chapter 2, Section 1, Inductive Reasoning. Inductive reasoning is the process of observing data, recognizing patterns, and making generalizations about those patterns. So we've got three examples here. Let's look at, see if we can determine, see if we can figure out the pattern and generalize what we're going to figure out what the next elements in that pattern is. So we've got 4, 2, -1, -5, -10. So I go down by 2, then I go down by 3, then I go down by 4, then I go down by 5. So my guess is I'm going to go down by 6 on the next pattern, next step. So I'd have -16, and then go down by 7, and then go down by 8, go down by 9, and so forth. Well, let's look at this next pattern. I go from 1 to 2, 2 to 4, 4 to 8, 8 to 16. Looks like I'm doubling it each time, so I'm timesing by 2. So my next number would be 32, and then 64, and so forth. This last one, we've got 1, 1, 2, 3, 5, 8, 13. This is actually a really well-known series, the Fibonacci sequence. So this number 2 is created by the sum of these. 3 by the sum of 1 and 2. 5, the sum of 2 and 3. 8, the sum of 3 and 8, 5. 13, the sum of 5 and 8. So the next number is the sum of 8 and 13, which would be 21. And the next number would be the sum of 13 and 21, and so forth. So let's look at this pattern. Let's see what we can identify and see if we can figure out, well, what are the next two steps? Okay, so we've got this black dot that moves here, then moves here, then moves here, then moves here. So my guess is the black dot's going to move there. So it'll be here, and then it'll move to here on steps 6 and 7. Then we've got this green dot. Let's see if we can figure out what's going on with the green dot. Goes to here, goes to here, goes to here, goes to here. So it's looking like it's making a step and a half. It's going to the next corner and the following corner. So it goes doon, like this. So it's taking a step and a half. So looks like it should go here with the green dot. Then I'll take another step and a half and there. So that's what step 6 and step 7, following the pattern of the first 5 steps, what it should look like. Okay, so let's look at this. We've got this setup here. Let's see if we can determine what the next step should look like. Here's step 1. It's a nice square. Step 2, we've got this square here is created. Then step 3, we've got this additional square. Step 4, you've got this smaller square. So what should step 5 look like? So based on what we've seen, this is what step 4 looked like. And here's what I think, based on the data, is step 5 will look like. We'll add this square. Now, why do I make this conjecture? Well, if I follow the pattern, in this small corner, I added a square that was a quarter of the original size. I then, in the opposite corner, I added another square. Then I went to this small corner, and I added that square. So I'm going to go with this corner and add this small square. That's my logic. But that's not the only possibility. Maybe the pattern was supposed to then add a square in this corner. So instead of instead of this corner being where the next smaller square, it starts up in here. And that seems like it follows the same sort of logic. I could see either either pattern applying in this case. So if I had step 5 written out for me, I think it would be much easier to figure out step 6, because the pattern concept there could have gone in either direction. So let's do a little bit of algebra review here. Let's graph this line. Y equals 3x minus 4. Well, this equation, y equals mx plus b, this is our slope-intercept equation. M is our slope. B is our y-intercept. So the slope is the rise over the run. The y-intercept is where the line crosses the y-axis. So -4, so it's crossing here at -4. 3 is the m, rise over run, so it's really 3 over 1. So it's going up 3 over 1, up 3 over 1, up 3 over 1. So our line ends up looking like this. That's our line. Y equals 3x minus 4. Let's do that again. Let's look at another one. Let's graph this line. Again, y equals mx plus b. That's the slope. That's the y-intercept. So 2 is the b, positive 2, so here, a positive 2. -3 over 4, so the -3 over 4. So it goes down 3, right 4. So down 3 over 4. So this is what our line looks like. I'm going to extend it in the other direction and demonstrate what it just did. So look at this. So I went down 3 over 4, but notice I can go back 4, up 3, and I get this another point where the line crosses in the coordinate plane. And that's the end of this lesson.